Okay, Taylor series, as I mentioned before, it allows us to approximate any function by a polynomial near a certain point. Yeah? Why do we want to do that? Because polynomials are easy to differentiate, it's easy to integrate. So it's a very convenient function to have. And to show that to you, we'll take an example. Here you see a function, the red one is the cosine of x. And we're going to try to approximate this function near the point x is 0. This is the point x is 0. So here is the polynomial which I wrote generally. So C0, C1, C2, C3, C4, these are the parameters. Yeah? And the way we're going to do it is, well, we're going to make sure that we hit certain KPIs so that our functions will be quite similar. Yeah? The first thing we're going to do is to make sure that both functions cross the y-axis at point 1. Yeah? So the first that we're going to do is the P of 0. When x is 0, these terms disappear, only C0 is left. And the cosine of 0 equals 1. Yeah? And we want them to be the same, so that means that C0 equals 1. So we found already the first parameter. Yeah? So they will intersect at the same level. The next thing we're going to do is, near that point 1, we'll make sure that the first order derivative matches. The first order derivative we're going to write as P prime x. Yeah, that is C1 plus 2C2 x plus 3C3 x squared plus 4C4 x to the power of 3. In the point x is 0, all these disappear. No? All these disappear. And we have x is 0. So we left with C1. Yeah. If we take the derivative of the cosine, we have minus sinus x and in 0 is 0. So this needs to be 0 in x0. So C1 has to be 0. C1 equals 0. Okay. So now we made sure that the first order derivative matches. Yeah, basically it means that, you know, these type of lines, they match. So close to 0, these will eventually match. Yeah. So here we have first one, this is the second one. Now we're gonna take the next order derivative. P double prime of x is 2C2 plus 3 times 2C3 x plus 4 times 3 C4 x squared. Yeah. When x is 0, we have 2C2. Yeah. And if we differentiate that one, the derivative of the sinus is the cosinus in the point 0 equals minus 1. So that's 1 with the minus is minus 1. So that means that 2C2 must be minus 1. So C2 equals minus a half. Okay. So here we make sure that the second order derivative match. Second order derivative makes sure that the curvature of these two functions is roughly the same. Yeah? So if we want to approximate the cosine in the point x by a polynomial, you would have p of x equals 1 minus half x squared. Yeah? This if you would stop at the second order derivative. And you can take the proof, the cosine of 0.1, or you do p of 0.1, and you will see that they're very, very close. So the stuff works. Okay, let's now go and take the third derivative, third order derivative. So this disappears, and here we have 3 times 2 times 1 C3 plus 4 times 3 times 2 C4x. When x is 0, this becomes 6C3. 6C3. 3 times 2 is 6C3. So that means if I derive that, cosine is minus sinus, so is plus sinus in 0, and that's 0. So that means 6C3 is 0. 6C3 equals 0. Means C3 equals 0. C3 equals 0. Now let's take the fourth derivative. So p and then 4 primes of x equals 4 times 3 times 2 times 1 C4. And I'll show you in a minute why I write this like this. The derivative of the sinus is the cosine in 0 equals 1. So here we have that 8 times 3 is 24. So 24 C4 need to be equal to 1. So that means that C4 equals 1 divided by 24. So now we found all the C's, and we've approximated the sinus near the point 0 by a polynomial. Now why did I write all this like this? It's because here you will find that this is 4 faculty. Here this is 3 faculty. So if we generalize this, we have that p of x equals 1 plus minus 1, so minus x squared divided by 2 faculty, plus 0x to the third divided by 3 faculty, plus x to the fourth divided by 4 faculty. So this is how we generalize. Alright, let's generalize. You have just a function f of x. First thing you do is calculate all the derivatives. And we know then in that case that p of x equals, we have f of x plus the f, first derivative, in the point x times x divided by 1 faculty, plus, and we just go on, d square f dx squared in the point x squared divided by 2 faculty, plus d3f dx to the third in the point x to the third divided by 3 faculty. That's how you're gonna approximate any function by a polynomial. Okay, this was it for the calculus refresher.